Audio.
Alrighty, are we live? Let's just maybe get some confirmation in the chat to make sure that everyone can hear us, people can see us. Welcome to this sort of walkthrough slash live stream all about Assignment 1 CSE Valley. Alvin, do we have audio and visuals all working? Let's check in chat.
I hope so.
Awesome. I hope so too. So that works out quite well. Alrighty, on the assumption that we have audio until I hear somebody telling me otherwise, welcome. So, first of all, I guess it's good to introduce ourselves. Alvin, do you want to introduce yourself first?
Sure. Hi. I'm Alvin. I currently am a tutor for 1511. I'm not sure what should I say in these things. And I'm currently on my third year doing computer science.
Cool. And Alvin is here because he is the wonderful main author of COMP1511 Assignment 1, which is CSE Valley. Yes, applause. Absolutely right.
Thank you.
There's a whole cast of people who've been involved in getting this working, but Alvin is the main author. So he's going to be walking us through a lot of Assignment 1 today. I'm also here. I'm Tom. I'm the course admin for COMP1511. Sasha is also here. She will be in the chat and possibly popping on mic every once in a while. And I'm hoping that we all know Sasha. So let's sort of do a quick overview of what we're planning on talking about today. Here's the outline. You can tell who's going to be speaking based on a secret code that we developed, T standing for Tom, and A standing for Alvin. So the first thing we're going to talk about, what is assignment 1 all about? What content are we covering? What do you have to do? Alvin's going to talk quickly about the inspiration for this game. I'm then going to sort of briefly cover some of the fundamental concepts that we'll need for this assignment. I'm also going to walk us through the specification for the assignment really quickly. You'll hear us call that the spec. Then Alvin is going to walk you through getting started. He'll also walk with you stage by stage, showing you everything in the assignment. And then at the end, Alvin and I together have sort of collated some tips about working on the assignment, things to keep in mind, all that sort of stuff. So please keep the questions coming in chat. If there are any really good questions, we will make sure that we answer them on stream. And Sasha is also going to be in the chat answering questions throughout. But let's get started. Let's chat about assignment 1. So what is assignment 1? Assignment 1 is the first major piece of coding work that many of you will have done. It's very exciting. It covers everything from week 1 to week 4 of COMP1511. So there's a list here of different things that it can involve. Int variables, we should probably also say doubles and chars and structs as well. If statements, all the sort of logical operators that you've seen, while loops, int arrays, struct arrays, two-dimensional arrays, printf and scanf, functions, and I think I already mentioned structs up the top there. So these are all the things that you've seen over the first 4 weeks. These are all the things that you're going to need in assignment 1. By the end of this week, you should have seen everything that you need. So the stuff that's coming up next week might be interesting, but you shouldn't have a need to use anything that's not particularly listed here. So what's the point of this? Well, it's 15% of your final mark. So I guess that's the point. But much more importantly, we want you to be working on a big piece of code. We want you to understand sort of what it's like to be working on a piece of software that you might have to work on in industry if you had to go into sort of working on larger pieces of software. You'll also have to have a little bit more of a focus on style. So unlike in the labs, style is assessed here. So one of the really important things is having code that not only works, but also that's readable. That said, the assignment's going to feel quite a lot like a large lab or a large series of labs. There's still auto tests. You still submit things in the same way. And hopefully the labs have prepared you well for doing the assignment now. There shouldn't be too many surprises. So that's sort of a brief summary of assignment 1. Alvin, would you like to talk a little bit about sort of the inspiration for assignment 1?
Yes, of course. Again, because like the name suggests, CSE Valley, it is actually based on a popular game called Stardew Valley. So the popular game itself is essentially an open-ended country life RPG or role-playing game. It's following the life of a farmer, so that farmer could, potentially farm, plan, and build relationships with people. Tom, can you go to the next slide?
Absolutely.
Yeah, so but CSE Valley in itself is the simplified version of that game. So as you can see, that is one of the pictures that I actually made, in a sense that you can only farm, and I think you can plant seeds as well. So if I were to change this to Stardew Valley, and as you can see, I'm getting paid to play Stardew Valley, which is amazing. But essentially, it's just mimicking the fact that everyone is in this 8x8 grid called farmland. So I believe in the code, we won't get into the code right now, but it's a 2D array of struct farmland or struct land, I think. And I guess the farmer is sort of stuck over here, and they can do certain things like, moving. So like, whenever you press a certain command or a certain key on the keyboard, so this will be different key, but the direction that the farmer is in will be watering that specific land. So now that particular water is now watered in that specific land. So this is just based on several movements that you can do in this game. And certainly when you harvest some plants or some seeds, then you'll get more seeds at the end. So there's no things like currency. There's time, but not really exactly what time is it, but it's only which day. But mainly it's based on a very simplified version of this CSE Valley game. So you'll be tasked with developing or trying to work out what commands or like what each command do, and so that the output would then need to be, if the farmer is moving left, then you'll go to the left. And going back to Tom.
Awesome. Thank you, Alvin. So what we're going to do now is talk through 4 things that I just thought would be important concepts that you're going to use throughout this assignment, that you might want to revise a little bit, or that we just want to give a quick sort of demo of, or a quick, just very simple walkthrough of. Hopefully, if you're looking at this, you'll say, yes, I understand everything that's there. If you're feeling like you see one of these things and you have no clue what's going on, don't worry. There's plenty of lab exercises to go and do. You can go back and look at the lectures as well, but this is just sort of the things that you might want to know before you get started. So the first one is the scanf and while loop. So we saw this already in lectures this week, I believe. So brief description, basically it's a while loop, but it's a while loop that continuously scans things in. I'm going to switch over to VLab to show you a very quick example. There we go. So here I've defined myself a character. I haven't initialized the character though, because I'm going to scan into it. I've built myself a while loop here. Oh, there we go. And inside the while loop, I'm continuously scanfing into C. And then as long as there is a character, so we write that as long as there is one thing that we've scanned in, I'm going to print out that character again. So just to walk through that again really quickly, I've initialized a variable. I've made myself a while loop. The condition of that while loop is that we scan something in. So we use this scanf to scan something in. Then we check if it's equal to 1, meaning have we scanned one thing in? And then we've got this printf here to print out that character. You'll note this space here. I'm just going to note that you're going to need, you will need to understand why that space is there. It has to do with white space. If you're not sure why it's there, I'd recommend going back, taking another look at the lectures, have a look at the labs, or you can post a question on the forums as well. But that is sort of a very simple example of while loops. You'll need to understand how you can apply that to work on this assignment. So how does this come up in the assignment? Well, as Alvin sort of mentioned, in the assignment, you're basically going to be scanning in commands. So you scan in a command and that forces you to do an action. It's kind of like if you have the up, down, left, right arrows on your keyboard. If you are moving around, there's a command for up, there's a command for down, there's a command for left, and there's a command for right. So that's why we'd use this sort of loop, and it's definitely something you'll be using throughout the day, or sorry, throughout the assignment, sorry. So that's scanf and while loop. Same thing again, the next thing we're going to talk about is structs. So brief description of structs. Structs are basically a way of putting multiple pieces of information together. So a simple example you might use is something like a coordinate. A coordinate has an integer for x and an integer for y. In this assignment, though, the structs all have names for things that actually could exist. So, for instance, we've got a plot of land, and a plot of land will have certain properties. Or there's a struct for the farmer, I believe, and that again could have certain properties. So let's take a look at a really simple example of this. Again, we'll jump back into VLab. So there are three important things to remember about structs. The first one is that we create this definition. Oh, and I've forgotten a semicolon there. So we need to create the idea of a struct. We need to say what is in a particular struct. So up here, we're saying that inside a struct called demo, this is a demonstration struct, there are two components to it. There is a thing called thing1, which is an integer, and something called thing2, which is a character. Now, this isn't a particular struct. This isn't, doesn't have values. It's just defining the idea of what a struct demo is. The second thing we need to do is then create a particular struct demo. So this creates a struct demo called myStruct. So here's a particular, now an instance of that struct. It's a particular thing that has particular values. And finally, I can access inside of that struct by saying myStruct.thing1. So for instance, I might say myStruct.thing1 equals 3. And similarly, I could say myStruct.thing2 equals character. So maybe it's A. Perfect. So that's structs. Now, where a struct's going to come up in this assignment? They're almost throughout the entire thing, because we use structs to represent the state of, for instance, as I said, a piece of land, or a seed, for instance. So these are all things that you'll be using throughout the assignment. The third thing, which you'll be using throughout the assignment, particularly in stage 1, is one-dimensional arrays. So arrays, remember, are multiple of the same type. So you can have, 5 integers or 5 structs. And the really handy thing about them is that you can access inside those structs using the square bracket operator. So for instance, you can write a while loop and go through all of them. Let's take another quick look at an example of that. VLab. So here is a one-dimensional array that we've created. So I've created this one-dimensional array. It's an array of integers, which is why it says int there. And it's got a particular size. In this case, it's got a size 3. So there are actually 3 integers inside this array. Now, with this particular array, I've initialized it so that everything in it is equal to 0. And we write that pretty much as equals curly bracket 0. There are some specifics to this. And again, if you're not quite sure about this, I recommend going back and looking at the lectures or the labs. Now, to access inside of that array, we can say array square brackets 0, for instance, and set that to be equal to 1. Now, the trick to remember is that arrays start counting at 0. So array 0 is the first element of the array. That's something that's you're going to need to remember throughout this assignment. Hopefully it's second nature to you, but if it's not, it's something to keep an eye out for. Another use of one-dimensional arrays that you'll particularly see throughout this assignment is struct arrays. So here is a struct array. It contains 5 struct demos. So we saw the struct demo above. It contains 5 of them. And it works pretty similarly. So we can say array 2 square bracket 0, access the first thing in array 2. And particularly, we want to set .thing1. So for instance, in this case, we're going to set the integer part of that struct to be equal to 5. That's a one-dimensional array, and particularly struct arrays are something that's going to come up. Finally, we can also talk about two-dimensional arrays. So we'll jump there. So a brief description of two-dimensional arrays. What if you liked arrays so much that I could put an array inside an array so you can array while you array? What do I mean by that? I mean, take an array and say that each element inside that array is another array. You might think, why is that useful? Why would you want that? Well, the answer is you can actually do kind of like a grid. You can have an X coordinate and a Y coordinate on it. So let's take a look at an example of that. Jumping back to VLab. Here is a really simple two-dimensional array. So it's a 5 by 5 array. And what you can imagine there is that we've got 1, 2, 3, 4, 5 integers, but we've actually got these 5 integers 5 times, like so. So what this means is each of these is an array, and inside those arrays are individual elements. So for instance, if you wanted to say array 1, 1 equals 7, what we're saying is go into the second array, because remember, arrays start at 0, so 0, 1. Going into this array, go into the second element, so we go 1, 2, and that's here. And we would update that array so that it's a 7. Now, where do these come up in this assignment? Mostly they're going to come up in the context of two-dimensional struct arrays, and particularly in the context of the farm. Because even if you look behind, Alvin and Sasha, and you take a look at the photos that are behind them, what you'll see is that there is a grid of different plants. And so that's definitely something which we need to be able to represent. If you're not too sure about that one, that's not going to come up too much until stage 2. So you can sort of get through stage 1 first and then come back to them if you're really worried. But definitely two-dimensional arrays are going to be something that will be coming up throughout this assignment. Alrighty. Whew. So that's a big walkthrough then of all the different types of content that you might want to revise before we start this assignment. The next thing that I want to do now is to talk you through the spec. So what do I mean when I say the spec? Let me just jump back into my web browser. When I say the spec, what I mean is the list of all of the instructions for this assignment. Here it is. Absolutely beautiful. I spent lots of time writing it for you. I'm hoping that everybody here will be able to, has already taken a look at it. If not, this will be a great time to take a first look. So let's have a quick walkthrough. At the top of the specification or the spec, you can find some basic information that just sort of explains what's going on. So when the Fire Nation started attacking COMP1511 land, they had to go back, citizens had to go back to basics, they needed to farm, and your job is to create a simulation called CSE Valley. So that's sort of the summary of why we're doing this assignment. There's an assignment live stream link. In fact, if you're here, you've already found that live stream, so well done. And what we'll do is we'll put a link to it here after the live stream, after the live stream is over. There's then some sort of overview information. So we'll explain to you what's in the world with a nice diagram. Thank you, Alvin. We'll explain to you the structs that we've given you in your code, and you can have a read through that in more detail. And I think Alvin's probably going to walk through that as well. Once you've done that, we'll also explain to you how commands work. So recall earlier we said you scan in commands, and those commands let you move around. They let you plant things. They let you scan in seeds, all sorts of things. But we're going to explain to you how they work. There's some information about allowed C features. So these are the things that you should be thinking about using. If there's other stuff that you know, or if there's other stuff that you learn in the next few weeks that's not on this list, don't worry. You probably don't need to use it in the assignment. Now you can use it, but given that we've completed this assignment without any of those things, we suggest that you avoid those features. As you can see, using other features won't increase your marks, and it could make you style mistakes that cost you marks. There is a reference implementation. I think Alvin is going to be going through the reference implementation in detail, but it's basically a description of how we want this program to function. And so if you're ever wondering how should this program work, you can look at the reference implementation and that'll tell you. There are these how to get started instructions. I think Alvin's going to be walking through those, if I'm not mistaken. And then there's a little bit of information about the starter code in particular. Finally, we get to this list of tasks. This is the meat of the assignment. This is what you're going to be working through. You'll notice that each stage has a little complexity indicator, and they're quite a lot like labs. So they've got little problems for you to solve. It's just that instead of submitting 7 things for a week, you submit one big project, and that's this. So each stage has a rationale, and then it also talks you through the different steps that we want you to do. Alvin's, I think, going to talk through those in more detail, but we just sort of want to give you the lay of the land first. So here's one section. It's about scanning things in. The next section is about printing things. The third section is a different way of printing things. And then there are some instructions on testing and submission. So here, what we're saying is basically you can run 1511 style to check your style. You can run the auto tests. So there are auto tests for this assignment. You can run those, and then you can also give your assignment. Remember, give early and give often. We really want you to keep giving and keep auto testing because it means that you've got a backup. If something goes wrong, if there's a backup there, it's really easy to fix. There's this handy table of commands, just as a reference for you. It shows you every command that you will need to implement over the course of the entire assignment. That's there. And finally, I think I've said finally twice now, but this is sort of the last section. And this last section is all of the information about the rules for this assignment. So mainly things like please don't plagiarize. In fact, you're not allowed to plagiarize. Rules about sharing your work, don't, basically, and information about sort of plagiarism and those sorts of things. There's information about submitting your work, and there's also an assessment scheme. So I think we've already mentioned it, but 80% of the marks come from the performance of your code. So we'll run auto tests kind of like the labs, and 20% of the marks come from style. So your tutors will have a look at your style and give you a mark based on that. There's way more information here for you to have read through. There's information about the due date. The assignment is due 25th of October. That's Monday of week 7, I believe, and information about the late penalty. We've also got a change log here. So if you ever sort of are wondering, did something change in the assignment, you can come here and double check. That is the entire spec. Now, I realize it seems like there might be a lot there, but we're going to walk through all the instructions in more detail. Alvin's going to do that in a moment. It might be useful. Let's just pause for a second. If there are any questions in the chat that are good questions, do we want to raise those now? We can give people a moment to bring them up. Anything relevant, Sasha or Alvin?
Oh, all good so far.
Perfect.
So I think Sienna actually raised a good question there as well, in that are we supposed to change things within the given structs? And I think Sasha replied with, you don't have to in the first few stages. So I believe there could be changes in stage 3 and 4, but that is depending on your implementation itself. So yes, definitely not in the first few stages.
Perfect. We might mention that again when we get up to talking about stage 3, just so that it's in the right place if people are skimming through. The one other thing that might be useful to mention now, especially talking about assessment, one thing that we've mentioned in the lecture, but really good to repeat, not everybody in this course is going to get 100% on the assignment. That's not the point of the assignment. This assignment, that there are things which we hope every single person will be able to complete, but there are also things which are designed to really push people who are wanting to get everything they can out of COMP1511. So we would recommend everybody should be aiming to finish at least stage 1 and stage 2. Those are the stages that are going to correspond with sort of all the things that we really want you to know for the exam. But if you're sort of sitting there and you're struggling with other courses, or you're sitting there and you don't want to keep going, that's okay. If you get sort of to, I'll jump up to the performance marks here. So as you can see, you could get 65% of your performance mark for a completely working implementation of stage 1 and stage 2. Anything above that, pretty much, if you're interested, if you want to, go ahead and do it. You'll learn lots of good stuff. You'll get set up for future courses. You'll get set up for lots of fun programming. But please don't feel like everybody needs to get 100%, because that's not the point. Do either of you want to add anything to that? Cool. Alrighty. So going back then to the schedule, which is here. Alvin, would you like to walk us through getting started?
Yes, of course. So I think getting started, you need to know where the assignment spec is. So here, if you click this S1, then it takes you to the assignment. And there are a few components that you can see here. There is some brief information about CSC Valley. So that is telling you what structs that we provide, what do you have to do in terms of the commands. I'm just running through, and I believe Tom has done that, and some features as well. But there are also 3 more things that I want to talk about. One is the table of commands. So these are the commands that you have to implement, and it is summarized through this table. So whenever you want to go to a specific command that you haven't finished, for instance, you can just click on, let's say 2.3, and it will take you straight to 2.3. So that's just a quick way to get through your assignment. But before we do that, I think there's a section in which allows you to download the things here. So mkdir is a command that makes a directory for assignment 1. So if you
Alvin,
just follow,
sorry, we can't see your screen. We can see Tom's screen.
Oh, sorry, I need to switch. Thank you so much. I have been scrolling through and not showing that. So as I was saying, damn, okay. There are a few things that I want to talk about today, but first of all, there's this how to get started section, and so we can just type up the command. So mkdir stands for make a directory, so we can then make a directory for assignment 1. So if we just do that, and hence we have the assignment 1 folder there that we can then change into, and we can download the starter code, or you can use this command. So I'm just gonna do that. Copy, paste, and as you can see now, we have this file called csc_valley.c. So when we open this file, you're given this file here that tells you how to get started, and this is your starter code. So you will want to replace these to-dos with your code for the assignment. And one important thing as well is to play the reference solution. So this is using this command of 1511 CSC Valley, and this allows you to essentially run the solution code that I made. And you can see if each behavior runs a certain way or the other, if you have something that's not really clear on the spec. And I think that's how you essentially get started. So I'm just gonna sort of run through what's inside this file over here. So as you can see, the farmer, which was the one that moves around, is declared as a struct farmer. So this farmer mostly tells you about where their current location is, so where their current column and when their current row is in the farm. And there's this thing called current direction, which we'll talk about over in stage 2. But essentially, a farmer exists, and as I was talking about as well, was the 2D array of farmland. So this is an array of two-dimensional arrays of struct len. So it's not just an array of integers, but it's an array of struct len, and struct len consists the status of whether a land is watered or if a land has a seed. And last but not least is the amount of seeds that a farmer currently contains, which is currently stored as an array of seeds, struct seeds. So this initialize functions essentially initializes each element inside the array or the variable. For instance, in initialize seeds, so you don't really have to know this, but it's just important to maybe try to understand, but you don't really need this essentially. But you know, like the farmer starts at the top left corner and facing to the right, whereas the land is initialized as not having watered and having no seed. Similarly, the seeds as well, the array of seeds is initialized as having no seed and essentially 0 amount if you have no seeds. And there's this print function that is important as well for stage 2. So this reference solution that I was talking about here is the solution that we keep referring ourselves into. So this is just like when you play the game, for instance. We'll talk about these shortly as well. And yes, and once you're done, make sure that you run this autotask command. So that is when you've done some coding and you want to test that code into our autotest, like your lab questions. So surely it will not pause anything so far because we haven't really done anything to the code, but this command exists. And don't forget, once you're done, I believe there will be a give command somewhere. I believe it's on bottom of each page. And once you're done, you can give this command, use this give command to submit your file. I'm just gonna Control C to stop this. And yeah, so that's how you get started. Does Sasha or Tom want to add anything to that before I move on to each stages?
Sounds good.
Okay.
That's good.
Cool. All right. So just to go on each stage, there are two main components of the assignment as well. One is the setup stage. So that's just 1.1, and the rest is handling commands. So I believe we talked about that on the commands. So there's this setup where, as you can see, if we were to run the reference solution, we will get 60 seats, and essentially this is dividing the seats into the array of seats that you can then use to plant it. And the rest is the game. So if we just speed through this, and then there's this enter command, this will run until whenever the user then press Control D. So for instance, if the user wants to see what the current state of the LAN looks like, then you can press L, and then it will print the LAN, and when it would still ask the command again until the user then press Control D. So let's go through to each stage right now. So with stage 1, as I talked about just now, we want to scan different seed names. So to get everyone started with their farms, all farmers will then receive 60 seeds each. And you will then be able to say how many different seeds you wish to have. So let's say, again, I keep running 1511 CSC Valley because this is the solution, so you can try things out before you then start coding. And let's say, you only want to wish to have one seed. That means one type of seed. So that means that all 60 seeds of the seed will then be on that one type. So let's say if I press 1, and it is in the screen, so enter the names of the seeds to be given. So when you enter the name of the seeds, make sure that they are a lowercase letter. So I think someone asked about, why is the maximum number of seed types is 26? And that's because there are 26 letters in the alphabet. And therefore, when you press something like V, which is a letter in the alphabet, and that is lowercase, you're done. Because so far you have scanned the different seeds, and because you only wanted one seed, then all of that seed is V. There are some assumptions that you need to think about as well. So with assumptions, essentially, you don't really have to worry about what if the user put in a number that's not between 1 to 5. You don't have to worry about that. And again, I guess for the name of the seeds, you also don't have to worry that the farmer will put in V and another V. So there will be different seed names. And the third assumption is that they will only put a lowercase letter. So if I were to do a different case here, so let's say I have 3 different seeds, one important key is that it will always scan in until it stops, until I have scanned in 3 things. So let's say with how many different seeds do you wish to have? So running this example file as well, you can kind of like run side by side. So here I could see that the example, let me kind of make the terminal a bit smaller. So let me try and see that, you know, this is B, C, A. So as you can see, because we currently receive 60 seats, then each seat, so you will have 20 B seats, 20 C seats, and 20 A seats at the end. So that's kind of the setup section of the assignment. I guess, are there any questions that I have been missing so far? Or are we good to go to the next part?
I think you're good.
Okay, cool. Thanks, Tom. So now we're entering the world of commands, in which the command would run indefinitely until the user presses Control D to end the command. So now, one of the first few commands is to print all the seats. So that is done by this command argument A. So if I were to type in A and I press enter, it will then list how many seats that each seat name has. So because, again, 60 divided by 3 was 20, then you will have 20 seats B, C, and A. So, you know, what is important about this is that you can have this command as many times as you would like, because this is just like basically getting this sort of inventory set up on the middle of my screen there. So that's just listing how many stuff you have, but currently it's only listing the number of seats that you have. So going back to VLab, yes, so every time you then press A, it will do the same thing regardless of anything, unless you plan the seats, which we'll talk to in the next command. So what's really important here is that whenever we press Control D, the program stops, and if we were to run another different thing, let's say B and C, then our A command, which is all the seats, will then be 30 seats of B and 30 seats of C. So yes, I believe, can we move on to the next command?
Looking good, I think.
Yes, so again, try to follow the examples and see if your output matches. Another way is to then run the auto test as well to see if you've passed any of the auto tests. So it's also important to then read the hints. So here you can see that I provided a hint to loop through the array of seat collections to access all the different seats. So you may find that important. And lastly, in stage 1, we have this printing one seat command. This command is specified by the character S followed by the seat name. But so, currently we have seat B and seat C. So if I were to say S, space B, and then I press enter, then you can see how it lists the amount of seats with the name B. So this is just specifying if there's one seat that the farmer wants, they want to know how many seats do they have of that specific seat name. But the important part about this stage is also that you have to consider some of the invalid inputs that exist. So let's say if the farmer puts in an invalid seat name, then your program should give an output of seat name has to be a lowercase letter. So your program has to accommodate for these. So one example here is that, what's a not lowercase letter? So maybe, I typed in a question mark. So then your program will have to print seat name has to be a lowercase letter. Similarly speaking, I guess if you don't actually have the seat that they were asking, then, so let's say, you only have currently B and C. So if you were to ask, oh, do I have seat A? Then I would say S, A, and then the error message, well, not error message, but the invalid input message should then be there is no seat with the name A. So it's not n because n here is then the seed name that you requested, which is then a. Again, there's an example here that you can follow through step by step. Oh, I happen to actually put down the right command. That's nice. And yes, so I could then press Control D to stop. And we're kind of done with stage 1. And I think at the very beginning I was talking about table of commands while still showing the Zoom call. But there's a table of commands in which it could just take you to the relevant stages directly. So if I want to go to 1.3, I mean, I could scroll up, but if I'm being fancy, I could just press 1.3 and it will take me straight back to 1.3. We have designed the assignment to not be so long. So this is just good to sort of like, if I want to move to stage 2 now, I could just press this 2.1 and it'll bring me to 2.1, which is printing len. So again, every time you run the program, you have to run the setup every time, but you only have to do that once. So currently, if I were to say how many different seeds I wish to have, say B, C, A. So game started because I've given 3 names of the seeds and they will receive 20 seeds each. And now we go to the next command, which is printing len. So
Alvin, before you
Yes.
go on, if you don't mind, the other thing I'll note is the end of a stage is a really great time to auto test and give. So you'll note that the end of each stage has those instructions there. I'd really recommend even the end of each like subtask, but definitely the end of each stage, auto test, style check, and give. The other thing which it might be worth noting as well, since we're at the top of a stage, is the top of each stage has a rationale, which sort of explains like why we were asking you to do these things. It's not like we're just sort of evil people who just sit in our lair all day, you know, mwahahaha, we can make you do things. No, we'll try and explain to you what you're going to get out of it, who we hope will complete it, and also how many marks you're going to get for it. So that's also a really useful page to take a look at.
Cool. Thank you, Tom. Dogs outside. And one thing to note as well, you don't have to run all the auto tests for all the stages straight away. So if you actually go down here, you can run a particular test for one stage by putting in this command. So this is running the test for stage 2. So if it's stage 1, then you can just change this of 201. So, but this will be on the bottom of each stage, I believe. So yes, that exists. So you don't have to worry about you can see like, oh, I passed 5 out of 5 tests, amazing. You know, I could move on, which is good. So talking about the first stage, the first part of stage 2, which is printing len. And as you've noticed, oh, I seem to remember there's a function that is in the starter code already, and you'll be right. We have given you a function called print len that you just can use. But currently, the starter code, if you run this starter code, actually, let's try and do that. So how to run your file, you know, dcc-o file name, which is csc_valley and csc_valley.c. Hey, it compiles. I mean, there's nothing, so it should compile. And you can see how this prints a len, although I guess you kind of need a new line after the enter command, but this kind of just prints that. But as we've discussed previously, you kind of want to keep entering commands, and whenever this printing command is summoned, which is from the argument L. So if we were to run 1511 CSC Valley again and run the setup BAC, you can see that if I press L, it will then print the len whenever we want to. So this is just the state of the len at any point at any given time. But more importantly, we have given you the print len function. You just need to use it whenever we give the L command. So this tests on your ability to use functions, which is pretty neat. And the second bit, which I find to be my favorite bit, is to move around the farm, because you can actually see and play out what happens when you play around the farm. So I believe this example is weirdly similar with one of the lectures this week, where Jax goes into a park. So that is definitely useful as a frame of reference. But as you can see, the command here has 4 commands to move right, left, up, and down. And that is from the characters of, I guess, bigger sign, lesser sign. Yep. I mean, it looks like, you know which way it is. So, and more importantly, so this, I think I was also talking about how struct farmer has a direction, and that is represented by this thing over here. So currently the farmer is on the top left corner heading to the right, right? So because it's heading to the right, then whenever you then press the right command here and try to print it again, oh, it's not F. I'm scared. What did F do? Len. You can see how the farmer actually moves forward, because currently the farmer is heading to the right, and then you give a right command, and then therefore the farmer moves to the right. So if I were to put the right command again, and then I print the len, you can see how the farmer has moved one step again. But more importantly, as you would do in your joystick, whenever you then want to move down, you would put the down command, VLAP. But as you can see, the farmer stays there, but it has changed its direction. So it was heading to the right, but now it's heading downwards. Only when you then go downwards again, then the farmer would then go downwards. So now you can see how the farmer is in row 1, column 2, and previously it was row 0, column 2. So there's that big direction challenge that you have to do. But again, so if I were to press the left command, then the farmer will not move, but it will just change its direction. And then only when I do it twice, then the farmer will move. One important note as well is that the farmer is stuck to that farmland. So currently if the farmer is here, the edge of row 1, column 0, when I press the left button again, the farmer will stay there. So the farmer can't escape the farm for now. So that is just an important thing to note. I guess Sasha and Tom, do you have anything to add on this bit? Nope. All right, cool. So there are some examples that I provided as well that talks about what I just said just now. And there's a really interesting GIFs that I made, which is really cool. But yes, you can see how which command that I entered there, you can see how it actually moves on that specific moment. Is there something in the chat? All right, so again, with this one, going to the command, you need to change the direction and then use the same command in order to move once, which is one of the other examples. So moving on to the next part of stage 2, which is 2.3, is to attend to an adjacent land. So what I mean by that here is that the farmer should then be able to take care of an adjacent land, so the land that they're currently facing. So let me restart the program and run it again. So 3BAC. So currently, farmer is back on top, facing to the right. And when you tend to adjacent land, so currently this farmer here is facing this land here. So the two things that they can do is that they can water and plant something to that adjacent land that they're facing. So with the water command, it is followed from the O command argument followed by the character W. So that is just saying space W, and then enter. And then as you can see, when I print land, now it is indicated by this W. What's important to note here is that we have done that in println for you, so you don't have to change anything inside of println in order to give this effect. So the water, every time a land is watered, then it will print by having the top right part of the land be having W. And yeah, similarly, the JSON line as well, you can plant a seed, but more importantly, you have to specify which seed name it has. So I forgot what seed names that I just made. So I'm just going to use the command A to find out, how many seeds and what seeds do I have right now. So that command A will say, hey, I have 20 seeds of B, A, C. And I think, so now I'm just going to plan a good seed name with probably A, because my name starts with A. And one thing to note here is that now there's a seed planted on that adjacent land, which is A. And more importantly, if I were to use the A command to get the status of the seeds that I currently have and not yet plant, I could see that now I only have 19 seeds with the name A, because I just used that one seed to be planted in the land. And again, you can read the invalid inputs and clarification. So let's say you can't certainly plant a seed that's off the edge, and you can't you can rewater the land, but it wouldn't really have any effect after it's being watered. But yes, anything to add, Sasha and Tom? Or are we good to go?
I might just very quickly answer the question. Just came in chat. Sasha posted a message about it. We realize the stream is running a little bit over. It's possible that we won't finish up for another 15 or 20 minutes. If you need to go, don't worry. The stream will be recorded. There'll be timestamps on the assignment page as well, so you can jump to the right place. Don't worry. But yes, we will be running a little bit over. Cool. Move on.
Cool. Thank you. Yes, so there's another set of diagrams as well, and planting as well, which is what I have just done. But again, you can then move downwards and then do the same command again in there. And the last part of stage 2 is scattering seeds. So this is a pretty cool stage in which you can then plant in 2 directions. One is to the right and one is to the bottom. So one thing to note is that when you use that command, it will plant the seeds from where you are to then the edge of the land. So if I were to right now say PB, and this is important here, and then I press L, you can see that I have replaced the seed A that I just had here, and then I have replaced it with B. So I started planting from where I am to the edge of the map. Similarly here is that I could do the same thing when I'm heading downwards. So if I were to use the command PB again, what I'll get is that I would then plan from where I am to the end of the farm. So this is just like, because there's some wind in CSC Valley that allows you to then plant all the way through one line from where you are to the edge of the farm, which is pretty cool. One thing to note here is then once you run out of seeds, which we'll show you in a minute. So now I only have seeds of B, right? So let me make some move commands. So I'm gonna go right, down, down, and see where I am. So I am currently here, right? So you can see how now I have 4 seeds B left, and then I'm currently facing downwards. And if I were to use that same command again, P and B, to plant downwards, I would still run this command. But as you can see, because I only have 4 seeds left, it's only gonna be printing this. I mean, it's gonna be planting these 4 plots here. So if I were to press L to show the current states of the land, then you can see how it doesn't plant on this bit of land and that bit of land. So yeah, that is sort of like the plan, the scattering seeds command. And there's some invalid inputs and clarifications, which is just like stage 1.3, in which, you know, you can only plant a lowercase letter. And then if you try to plant a seed that you don't have, it would have to say that as well. So yes, that is the end of stage 2. Can we just move on to stage 3 then, Tom and Sasha? All right.
Yep.
So moving on to stage 3, I could just press that. Stage 3. This is there are a few more functions, I promise. And if you can see in the table of commands, this kind of has a good summary of what the commands that I just have. So if you want less words, this is where you go. So the next command is then watering a square. This is perfect because with watering square, there's 2 arguments. One is W to make sure that you know it's a watering square. And then the second one is the size. But the size is actually like the radius, but not really radius, but like, but it's the size of the water that you are gonna water straight away. So here is the ability of God of Rain, so that you will just rain that whole square patch there. So as you can see, if I am in row 2 and column 3, and I could read that there, then if I were to type in W2, so let me actually get it similarly. So row 2, column 3, so I probably just need to go to the right twice, and I am in the right spot, I think. And if I were to then put W2, I can see that everything here, the surrounding areas, will then be watered, which is what is happening right here. One thing to note as well is that if you are near the edges, so if I were to run this command on the top left corner, technically with the size 1, I would be watering some negative, some farm that's not really my farm because it's outside of my farm, but it will still run the command. It will just water the land that is in fact in your land. So yeah, I think we can then move on to the next stage if there are no questions. Yes, it is a valid. Yep, yeah. Go on, Tom.
You want to answer it?
Yes, it is. I have done solid Stardew Valley research, yes.
The comment I would make is don't play too much Stardew Valley. You want to make your game so good that you want to play it instead of Stardew Valley. So a little bit of research is okay. Too much research, you can go back to writing some code. But yes.
True. So the next thing that I want to talk about is the second part, which is this advancing to the next day and harvesting. So just like in Stardew Valley where you can go to sleep and it becomes the next day. This is sort of similar in which then you can go to the next day. And there are a few things that happen when you go to the next day, which is that the seeds that are not planted, sorry, the seeds that is not watered will die. And then the seed that is watered would actually grow. And this is interesting here. So we can try to use that command straight away. So I think the command is n. So going to n here, it is also notable that you have to print which day you are currently in. So also one thing to note is with stage 3, there may be some changes that you want to make in your current structs. So maybe, to accommodate the number of days, you can potentially put that somewhere. So, printing the L command to show what the state of the land is, you can see there are a few things that have happened. Firstly, my farmer has moved. Now it's going back to the top left corner, facing to the right. And you can see how the only watered ones have grown into a seed, a plant that is ready to be harvested. And that is also indicated by it being the uppercase form of the letter. So you can see how this B is uppercase. And what's important to note here is that now whenever you see plants that are ready to be harvested, you can then try to harvest it by using the H command. So the H command would then harvest an adjacent land. So it kind of works similarly with watering adjacent and planting adjacent. So what happens when you harvest, so when I press the character H, this will be printed, which is plant B was harvested, resulting in 5 B seeds. Right, so whenever you harvest a plant, it directly translates to you getting a 5 seeds of its same type. Right, so plant B was harvested, you get 5 lowercase b, which means that, and I think we ran out of B seeds for once. So if I were to press A command, I should have 5 B seeds right now, which is what is happening. Right? Because I ran out of B seeds and then now I would have 5 B seeds. One thing to note as well is that, if I go back to my land, you can see that I just harvest that particular plant and now it's gone after it's being harvested. And more importantly, if I were to leave this harvestable plant and go to sleep and not harvest it, so I go to the next day and I press N. So again, this will be day 3. And then when I press L command, you can see that all the harvestable plants that I didn't harvest because I go to sleep will be gone. So those are the things that you have to consider, and there may be some changes to the current structs to accommodate for those changes. So are there any questions from the chat that I should be answering?
Nope, I think that's all good.
All right. So the next thing is trading seeds. So you can trade a few seeds with your friends. I guess not directly, but then there's a market which allows you to trade one seed for another seed. So every seed kind of has the same value. And there's that trade command. So if I were to put A to find out how many current seeds that I currently have, and if VLab wants to respond to me. So I do have 5 seeds of B, A, and C. There are a few things to note as well, as per usual. So say you can't trade in a negative number, but the command arguments that I want to raise is that it starts with T and the seed that you have. So let's say I have B's, I want to trade my B seeds, and its amount. So let's say I want to trade in 5 of my B seeds, not 55, 5. And what is the name of the seed that I want to trade for? So currently, if I want to trade it for my seed A, so I expect that I would have 0 seeds B left, and then I would have 24 seeds A left. And then if I were to run the A command, you can see that is what happened. What's important to note is that 0 seeds still stays. So it's not like you stop printing B seeds. Once a seed has been initialized, it will stay there. Another important thing that I want to note here is that whenever you try to trade a seed that you currently don't have, so let's say I'm trading 12 of my A seeds to a seed called D, what then happens is that 12 seeds D will be now printed first. So there needs to be some shifting going on, but that's a bit of the challenge for this stage. There are some other things to note in which that you don't have to trade negative seeds as well. Yes, so those are the things that you have to work for. So with the more stages you go through, like I guess the last examples will give you. So I guess, Tom, should we currently move on to stage 4 if there are no questions about trading?
I don't think there are any questions about trading. Obviously, same as stage 1 and stage 2. Once you get to the end of a stage, even the end of a task, make sure you test, run style, and give. But we can go on to stage 4.
And importantly, you also run the style here to see if you have written the good style as well, which is a good thing. So going to stage 4, and I wouldn't try to replicate this because there's a lot of commands needed to be done for it. But in 1511 land, there's also natural disasters, which is droughts and also windstorms. So the main difference between the two is that whenever you have a drought, you don't want a lot of plants to be nearby each plant. So let's say, so currently that command is specified by the character D and D and the minimum number of plants, so that the plant's adjacent lands for a plant to die within this command. But what that means is that you can see how this B seed there has 8 adjacent seeds nearby or plants nearby. So what that means is that in a drought, this plant would die if I were to say the command dd5, and that's because when a plant has 5 other plants in their adjacent land, it will not live after the drought, because soil nutrients is then very important when it gets to drought, because they need to take nutrients, and if there's too many plants, then it will die. So this plant, for instance, survive because you can see how it only has 3 adjacent plants nearby, and because the number of minimum plants to die is 5, then this plant then survive. So yes, so any more than 5 plants, or I think the minimum number of 5, then that plant cease to exist. Anything to add on that one, Tom?
Nope, I think that covers it really well.
All right, and on the opposite hand, if you have a windstorm, you actually need those plants to stick together. So it's the same exact structure here, but except that it's the W and the minimum number of plants in order to survive. Because if you have a windstorm, it's good to stick together to build a better structure. So, likewise, this plant will survive because it has 8 friends, right? And the minimum number to survive is 5. Whereas this corner plant here that used to survive in a drought now wouldn't survive because now it only has 3 plants adjacent, and therefore it's less than 5, and therefore it ceased to exist. because there's no strong surroundings. So that is sort of a quick run through to stage 4. And as per usual, you can run the auto test, which pretty much will run the 2 examples I just showed you to see whether you've got it right. So I think we'll move back to Tom and Zoom, I suppose.
Cool.
And what is the next bit?
So the next bit and the last bit is just some tips. So this is sort of collated advice. I've got some advice written down. I know Alvin may also have things to add, Sasha as well. I'll also note this would be a great time if you've got questions. Once we finish this little advice section, we'll stick around and we'll just go through the questions. After that point, obviously, you won't have to stick around, but if there'll be anything that you really want to ask us, you can ask that in the chat. So just to really call out for that now. So I've split my advice and sort of notes into 5 separate things. Planning, getting help, style, what to do if you can't solve something, and finally, testing. So first of all, planning. You will hear every tutor say this: get started early. Get started today. Just get something going. Even if you're not going that far through it, getting started early just gives you more time and more flexibility. I know as uni students, we might not want to do that. I'm guilty of that. But definitely getting started early is really, really important. I also recommend setting like some milestones for yourself. So particularly if you just say, oh, I'd like to try and get, stage 1 done this week or stage 1 done by the middle of next week, even if that's entirely inaccurate, it's good to have that sort of little goal setting for yourself. I'd recommend that. There was some discussion about this in the chat. You need to go in order. So the later stages rely on the early stages. You can't go out of order. As we've said multiple times already, give early and give often. It is really important to every time you get through a small thing, give early, auto test. That's really, really important. The final thing is when you're planning, I would recommend planning to try and do things in small steps. A not great plan would be to say, I'm going to do everything on Sunday evening. Not a good plan. I've done that before. I wouldn't recommend it. But so we really suggest, work in small chunks and work progressively. That's planning. Second of all, getting help. There are lots of places you can go to ask for help. Help sessions, really great. Forums, really great. And your labs as well, really good places. Help sessions, just be wary. They will get very busy near to the end of the assignment period, so go early. It's another benefit of starting early. One place that we don't recommend getting help, in fact, you cannot get help from, is don't collaborate with your friends on this assignment. This is an individual assignment. If you're sharing code or you're sharing anything that even seems like code, that could be plagiarism, and that's something we really, really don't want. If you get to the situation where you feel like all hope is lost, I've got no choice other than going to talk to my friend Bob and getting his assignment solution. If you're in that situation, email the class account or get in touch with your tutor. We have other avenues to help you. Please don't just go and do that, because if you do that, all manner of bad consequences can happen, and we don't want to see that happen for anybody. That's getting help. On style. Style is free marks. You can get put up an entire grade, from a credit to a distinction, or from a distinction to an HD based solely on your style. So it is really, really it's not just a little thing. It's a really important part of this assignment. The best way to work on style is to keep having consistently good style. I don't recommend getting started, doing all of your code, and then at the end saying, okay, now it's time for style. Because if you do that, you'll go back to the pieces of code you've written earlier and you will just not know what's going on. You will not be able to understand it. So every time you submit, just run 1511 style. Every time you're having a think about, how could I structure this better? Do a small change. It won't feel like you're having to do any work, and it'll just make your life a lot easier. Also, we recommend using functions where you can. In the first stage, you might find that it doesn't make sense to use functions, but especially as you go through the assignment, you'll notice places where functions seem really, really useful. They will make your code read better. They will help with style marks. They will make your life easier. So we definitely recommend functions. Cool, that's style. What to do if you can't solve something? So first thing to say is when you're trying to solve something, if you've spent a while on it, take a break. You don't need to keep pushing and pushing and pushing until you solve something. Especially what can happen is you're up till 2 a.m. You're trying to solve one thing and you're just like, if I keep going, I'll solve it. If you have a sleep, you might find that you could just solve the thing instantly the next morning. So take a break. It's good to have regular breaks while you're working on this. Solve things one error at a time. I think Sasha's probably going to talk about this a lot more in the debugging lecture. I think it's next week. But you want to start at the first error and sort of solve one thing at a time. Don't try and get everything working. Just solve little things, because each little thing you solve, you can compile again and then double check that things work. It is really important to compile regularly as well, so that you can find out, have I made a mistake that I need to solve? Finally, on testing, there was a really great question earlier about testing, particularly about, do I need to write my own tests? Do I need to do my own testing? Here is how I would explain that. When we write our tests, especially for the early stages, we're not planning on missing anything out. We're not intentionally leaving a massive gap in the assignment. But we're human, and also we can't write tests for every single possible edge case. So what that means is, when you're doing your own testing, have a think about, well, the auto tests, what happens if the farmer goes all the way to the bottom of the map? What happens if my farmer goes all the way to the side of the map? Have a think about these little edge cases. Yes, we're human. Have a think about all these little edge cases and try and find your own. That's not to say that you won't get, a reasonably good mark if, you accidentally miss one little edge case. But what we're wanting you to do is to use our auto tests as a starting point and just make sure that there's nothing else you can think of that we need to check. With testing, like I said, the auto tests are a good indication that you're on the right track, but make sure that you test your own cases and just make sure that we're not missing out on anything. That's testing. I think that's all of the advice that I wanted to give. Sasha or Alvin, would you like to add any advice?
I think you've covered it pretty well, but most importantly, just start early.
Yep.
And because then, lots of help is available to you, lots more help. And if you start early, then you can afford to just do an hour a night, and then, that's it. You don't have to do this crazy, stressful, 8-hour marathon where you don't, you're barely kind of staying awake.
High on caffeine. That sort of thing. Yeah. There's also one other thing which I wrote right at the top of my notebook here, to have fun. We've designed this assignment not just to be, checking out the stuff that you've already done. We want you to have fun. We want it to be interesting. We want it to be engaging. So please don't forget why you're doing this. Feel sorry for our farmer, or feel vindictive as you have natural disasters and stuff. But do have some fun with it. We don't want this to be a super stressful experience. And if you're feeling really, really stressed about it, if you don't feel okay, there are plenty of support services that we can link you to, or you can have a chat to your tutor. So please do, in fact, have fun. Anything else that I missed, Alvin, as well?
I think what I kind of want to say is I think it could be a bit harder for people who haven't had any programming experience before, because this is their largest ever project, right? I think the starter code themselves is 217 lines, and that's before any of your code. So yes, it could feel a bit tough, but if you have any concerns or problems, ask your tutor, ask the forum. We'll try our best to read everything and answer your questions. Again, this is meant to be a fun experience for you, and we want to keep it fun. We know lockdown has been long enough. I know next week is Freedom Day, but we kind of want to make this fun for you. So please reach out if you had any troubles, and we will try our best to answer all your questions to you. And I believe someone asked, can we run the code with parts of the assignment not done? Yes, you can. But the problem is also you have to make sure that you are passing the output just like how you would do it in your current labs. But again, if you've only done parts of stage 2, that's fine. Like, as long as you've done a specific command and it works, then that's all you need. So you can do parts of stages, and it doesn't have to be all of the stages or all of the assignments for you to submit. You can submit per stage or even per command.
Yeah. So there's another question there. What should we do if we can't get our code to run properly, but the majority of it is correct? Do we still submit? That's a great question. So if you've got an error that means that your entire code doesn't work at all, we'd suggest going and having a look at your auto test history and maybe trying to start from the bit of code that works. Because having, a fully functional 90% of the assignment is better than having an assignment that's, got a bunch of mess everywhere and doesn't quite work. But you're absolutely able to, submit, as Alvin said, part of your code, but not the whole thing. That's definitely something that's okay to do. There's another point there about Nicholas has raised that you can bring stuff to tutors. Absolutely, you can. You can definitely bring your assignment work to tutors or at a help session. So if you're in that situation where something's not quite working and you're not sure why, that is a really good time to go and talk to a tutor. I realized that I did just mention just then one other thing which might be quite useful to mention, which is that you do have access to the history of all of your tests. So I will just jump in here so you can see it really quickly. I'm hoping that you may have seen this already. Your tutor may have showed it to you. You may have seen it in the intro video, but this is a list of every single auto test that you've done. So you can go back in time and have a look at previous auto tests. You can restore your history if you accidentally break something. This is a really useful tool as well that I can definitely recommend. That I think is all I want to say about that. Any other questions? Anything at all? We'll throw it back out to the chat. Is there anything there that people would like to
I think if you were to press each test, Tom, so any of the red ones, you can see when the error occurs and also what the input for the test is down below, I believe. So if you were to just replicate, input for this test is bit. So it scroll a bit down. Yep, that one. So you can see that, if you just replicate that error, so run that into your own DCC, your own terminal, and run that and see whether you've got so what I would like to do is to have your code on one terminal and the reference implementation on one terminal, and you putting down the same commands to check by line if your code is actually the same with the reference implementation. That's all I wanted to say on that one.
Sorry, there is a great question here about how do you access this. Go up to the submissions button at the top. This is on on the assignment pages and on the front page. Press submissions, log in, and then there will be basically an option there for the assignment 1 auto test history, the yellow button. So just have a look for that. And if you're not sure where to find it, go and talk to your tutor. I unfortunately can't show you on this machine, but you can jump into your auto test history there. Any other questions? Anything else that people are wondering about? That we can things that we can cover. We've run a little bit over time, so there may be some people who've already left and I'll be watching this recording later. One other thing which it might be worth doing really quickly is just to shout out to all the tutors who have helped working on this. Obviously, Alvin has spent a large amount of time working on this, so we're very grateful to him. But there are also people who've worked on testing the solution. So Shrey as well has been a big help in a lot of this, and there's plenty of other names of people who I could say as well. So the assignment is the work of a bunch of our tutors. So make sure say thank you to your tutors, and cool. I don't see any other questions. So we'll just sort of make stuff up for the next 30 seconds, and I suppose we can finish up at 8 o'clock. I'll mention, it might be worth mentioning as well really quickly, just sort of at the end here. We've spoken about help sessions quite a bit. If you're interested in where those help sessions are, you can go to the list of help sessions, which is here. So if you click on that, you'll be able to see a list of all of the help sessions that we're running this time. So that's just a useful, handy thing to know as well.
Good luck, everyone.
Yeah, good luck, everyone. I hope you enjoy yourselves.
Looking forward to seeing all your code.
Absolutely. Feel like the odd one out here.